Hey everyone, so in this video we are going to talk about lesson 2.1, which is all about complex numbers. And specifically talking about complex numbers, we are going to learn how to add, subtract, multiply, and divide complex numbers. So we are going to apply operations to complex numbers, and then we are also going to be able to solve quadratic equations with non-real solutions. So I just want to get started with this little review here. Solving using the quadratic formula. So now let's remember the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a, okay? And so quadratic formula solves for x. And so let's get started with this equation. We'll have x equals the opposite of b. So if b is a -2, opposite of -2 is +2, plus or minus the square root of b squared minus 4 times a times c divided by 2 times a, okay? So you can see everywhere I inputted a number, I put it in parentheses. And then let's go ahead and start to simplify this. So I have 2 plus or minus -2 squared is going to give me 4 minus, and then I look right here at this part here, -4 times 1 is -4. -4 times -6 is a +24, all over 2 times 1, which is 2. So then I have x equals 2 plus or minus the square root of 4 plus 24 is 28, divided by 2. On the side, I come over and I want to break down 28, so I use a factor tree. I'm going to do square root of 4 and the square root of 7, so that gives me 2 square root 7. So then I get 2 plus or minus 2 square root 7. This gets over 2, and this gets over 2. And so I can rewrite that as 2 divided by 2 is 1 plus or minus square root 7 because the 2 over 2's cancel. Okay, so just a review of the quadratic formula that should be very familiar to us. And now let's just define here complex numbers and imaginary numbers. The imaginary unit, I, is defined as, we have to remember both of these definitions. I equals the square root of -1. And then think about it, if you square both sides, we're going to end up with I squared equals -1. These are two very important definitions we are going to use in this lesson and throughout this course. We also remember that complex numbers are in this form, a plus bi, where we have the real number first. The real number is a, and then the bi is your imaginary unit, okay? And that creates a complex number. Standard form, like I was just saying, is a plus bi. You always want the real part first and then the imaginary part second. So when we simplify, notice here we're adding and subtracting complex numbers. We're really just combining like terms. So I'm going to add my real numbers, and then I'm going to add my imaginary numbers. -2i plus 3i is going to give me +1i. Okay, notice that's in the standard form of a complex number, real number first, imaginary part second. And now I'm subtracting, so I have 2 minus 12 is going to give me -10. And then be very careful here, and I do like to write this out. 6i minus -i. We have a subtracting a negative, so that's going to become plus 7i. And a lot of times, guys, we forget to distribute that subtraction to that second term, that imaginary number there. So be very careful with that. Next, let's practice multiplying complex numbers. And we're going to treat this just like we would with real numbers. Notice A, there's a number in front of parentheses. When there's a number in front of parentheses, typically that means for us to distribute, right? So we're going to distribute that 7i to everything in the parentheses. So I'm going to have 14i minus 63. I times I is going to give me I squared. And let's just remember our definitions. I squared equals -1, and I equals the square root of -1. And that's important because now I can simplify this because I know I squared equals -1. So in for I squared, I'm going to substitute in a -1. And so then I will have 14i plus 63, and I will need to write this in that standard form of a complex number. So I have 63 plus 14i is my answer. Okay, real part first, imaginary part second. Notice in B, we are not going to be distributing, kind of form of distributing, we're going to be FOILing. We have two binomials. So I'm going to multiply the 5 times everything in the second binomial, and then the 4i times everything in the second binomial. So I'll have 5 times 6 gives me 30. 5 times negative 7i is negative 35i. 4i times 6 is 24i. 4i times negative 7i is negative 28i squared, right? I times I is I squared. Let's see what we can simplify. We can do negative 35i plus 24i. That's going to give us negative 11i minus 28. I'm going to substitute that negative 1 in for I squared, which then lets us make this a 28, a plus a 28. Negative 28 times negative 1 is 28. We can combine some like terms here, and I'm going to get my final answer is 58 minus 11i. Real number first, imaginary part second. The next part when it comes to dividing complex numbers is we have to remember that we are not allowed to have i's in the denominator. So for the complex number a plus bi, we define its complex conjugate to be a plus bi. The product of a complex conjugate, the product of a complex number and its conjugate is a real number, which is what we want because we can only have real numbers in denominators of fractions. So remember, conjugates, they're just the same exact binomial, but different signs, okay? So if we were given a minus bi, the conjugate would be a plus bi. And when we multiply conjugates, we always get a real number, which means our i's are going to go away. And I can show you what happens in this one. We'll have a times a squared. A times negative bi, negative a bi. Bi times a is a positive a bi. And negative bi squared, oh, actually negative b squared, I squared. And notice this is going to cancel. And then you'll have a squared minus b squared times I squared. Remember our definition, I squared equals negative 1. And so notice when we simplify that, our imaginary numbers are gone, and I'm left with a real number, which is what we want in fractions in the denominator. So in our last example here, oh, two more, I want to show you how we are going to get rid of the I in the denominator, and we're going to divide. And in order to divide, we have to multiply by that complex conjugate. So I'm going to multiply the numerator and the denominator by the conjugate of the denominator. Same binomial as the denominator, just opposite signs. And so then we're going to need to FOIL your numerator and denominator. So I'll have 5 times 4, 5 times I, 4i times 4, 4i times I. All over 4 times 4, 4 times I, negative I times 4 minus I squared. And next, what we'll need to do is combine like terms, simplify where we can. So I'm going to have 20 plus 5i minus 6 plus 16i, we'll get plus 21i, plus 4 times negative 1. Notice 4i minus 4i cancels, so we'll have 16 minus I squared, and I'll substitute in that negative 1. Then we'll be able to write this as 20 plus 21 I minus 4 all over 16 plus 1. Combine like terms, we'll have 16 plus 21i over 17. Okay, so notice here, our denominator is now a real number, and it doesn't have any imaginary numbers in it. So we have been able to write this rational expression with complex numbers properly without any imaginary numbers in our denominator. The last piece, in order to get this in standard form, is we need to write it as 16 over 17 plus 21i over 17. So then you can really see, here's your a, your real number, and then here's the bi, the imaginary part, 21i over 17. And then in this last example, guys, we are going to practice solving using the quadratic formula. And when we do this, we might get an imaginary number in our answer. So let's get started using the quadratic formula. We'll have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Let's simplify where we can. Negative 2 squared is going to give me 4. Negative 4 times 1 is negative 4 times 2 is negative 8. So then we'll have 2 plus or minus the square root of negative 4 over 2. Let's remember how we handle the square root of negative numbers. So square root of negative 4 is the same thing as the square root of 4 times the square root of negative 1. Square root of 4 is going to give me 2, and we know square root of negative 1 is I. So then I can write this as 2 plus or minus 2i. This gets over 2, this gets over 2, and I'm left with 1 plus or minus I is my answer to this equation. That's my solutions. Okay, so this is a good review on complex numbers, how to apply operations to them, and then also how to solve quadratic equations that involve imaginary numbers. Great job, guys. Keep up the great work.